All right, today you're going to solve quadratic equations by factoring. And the premise of this is the zero product property. And I misspelled it because you're actually going to make a T on the paper. So what the zero product property says is if you have a first thing times a second thing equals to 0, then either one of those could be 0. So if A was 0, B could be anything, and the answer is 0. If B was 0, then A could be anything, and the answer is still 0. That's what the zero product property says. So what we do is we have a quadratic here. It's already factored. It's in factored form. We know it's a quadratic because A times A is A squared. So this would be a quadratic, something squared. So what we do is we get it into factored form, and then we make a T, and we set each factor equal to 0. So we're going to solve for A. So A plus 1 is equal to 0. A plus 2 is equal to 0. And you're going to get two answers out of this. So subtract 1 over, and we get A is equal to negative 1. Okay, subtract the 2 over, and we get A is equal to negative 2. So I have solved this quadratic by factoring, but I didn't have to factor this one because it was already factored. The other important thing is you must have your quadratic set equal to 0. Okay, so you have to have that in order to say this thing times this thing is equal to 0. So set equal to 0. That's very important. It has to be set equal to 0. So for example, I'm going to jump down to number 6. On problem number 6, we have a quadratic, but it's not set equal to 0. So we got to bring this 5 over to the other side of the equation to make that 0. So it's a positive 5, so I do the opposite. So I subtract 5 from each side. I get n squared plus 7n plus 10. Now the next step is to, so step 1 is make sure it's set equal to 0. Step 2 is to factor. So make our two sets of parentheses, put an x in each. Oh, no, it's an n this time, so n and n. We multiply to make the last number, and we add to make the middle number. Right away, 2 and 5 come to mind, and they're both positive. So that's how that factors. So you got to use your factoring skills. Now we're going to set each factor equal to 0. So n plus 2 is equal to 0, n plus 5 is equal to 0. We subtract the 2 over, we get n is negative 2. We subtract the 5 over, n is negative 5. So the reason why this works is because we have a parabola. This graph right here is a parabola, and this parabola bends. So it's going to, we're looking for where the parabola is 0. 1, 2, put a dot. 3, 4, 5, put a dot. So what happens is this is a happy parabola instead of a sad parabola because it has a positive there. And the parabola is going to come down. It's going to go through negative 5, and it's going to go through negative 2 because that's where it crosses the x-axis. That's the 0 of the function where it crosses the x-axis. There's 3 names to these points. We call them the x-intercepts, right? We call them the zeros of the function. That's what we're looking for. And we call them the roots of the equation. So if you're looking for zeros, roots, or the x-intercept, it all means where does the function, where does the graph cross the x-axis. And why is that true? Because the function or the parabola or whatever you want to call it is set equal to 0. So now the factoring is going to be the biggest obstacle for this. So for example, this one looks kind of challenging, but it's not too bad. We're going to make it equal to 0. That's step 1. So we move the 6 over. We get 6n squared minus 18n minus 24. Now, we always want to look for a GCF. So that's part of it. When you factor, before you make the two sets of parentheses, is there a GCF? That's a big deal. So we look at this, and to me, it just jumps out at me that each one of those is divisible by 6. So I'm going to actually divide that common factor of 6 out because I can make it much simpler. And what you do to one side of the equation, you do the other. And it keeps the solution the same even though we're dividing the parabola by 6. So this is still 0, so it's still set equal to 0. This is 4. This would be 3, so minus 3n. And then this would be n squared. So now we do the two sets of parentheses, put an n in each. And what do we got going on here? 4 2 and 2 won't make the 3, so what, 4 and 1? So we're going to subtract the 4, add the 1 equals 0. So now we can do our t, make our t, 0 product proper t. So n minus 4 is equal to 0, n plus 1 is equal to 0. So n is equal to 4, because I add the 4 over, subtract the 1 over, n equals negative 1. So that's the answer to this one. Now if you write a little bit smaller, you don't have to worry about that, but I did take out the common factor. That will happen on this one. What do you think the common factor is for when we add the 7 over the 14 to 7? It's kind of obvious, right? If you do 7, 14, so 7 is the GCF. So when you do number 10, look for the GCF of 7. You're going to factor that out or divide it out or whatever of the solution. So the front page is pretty straightforward. Let's look at the back page here. We didn't really talk about this kind of factoring here, so some of these we're going to have to skip. I will worry about that. We can certainly do number 14. So we're going to do subtract over 3b, because we got to get it equal to 0. And let's see, we get b squared plus 2b minus 35 is equal to 0. And we get b and b in my parentheses. So when you factor, put the letters first, right? Put the numbers second, then the symbols last. 7, 7, 7, 7. Yes, 7. 7 and 5. So that's supposed to be a b there. Plus 7 minus 5. Yep, that makes the positive 2 in the middle. And 0 product proper t says that b plus 7 is equal to 0. b minus 5 equals 0. And then, oh, I went off the screen. b plus 7, b minus 5 equals 0. Subtract the 7 over. b equals negative 7. Add the 5 over. b equals 5. And those are the two answers. All right, let me pause it here and see which ones we're going to eliminate. Okay, I looked this over. We're going to eliminate number 15, number 18, number 20, and 21 and 22. But I'd like to go over one more with you. Let's look at this one here. This one looks horrendous. So we're going to get everything to one side. So I'm going to add over 5k squared, because you got to set these equal to 0. And we're going to add over 3. You always do the opposite to move stuff, right? So that's minus, so I'm going to add over the 3. That's minus, so I'm going to add over the k squared. So we get k squared. This falls down, minus 8k. And then that would be 0. So you're like, okay, well, how do I factor that? Well, what's the first thing you're always supposed to look for? GCF, greatest common factor. Well, here, the GCF is k. So k comes out to the front. So the GCF is k. So k times something makes k squared. Oh, whoops, not k squared. My bad. K times k makes k squared, so there's no squared there. So it's k times k makes k squared, and then I need a negative 8. Then I'm going to do 0 product proper t. Set each factor equal to 0. Now k equals 0. There's nothing to solve there, but that is one of the solutions. And then I add the 8 over, and then I get k is equal to 8. So there's actually, the question you should be asking is, what do I do if the quadratic doesn't factor? Is there a way to solve it? Yes. It's called the quadratic formula, and that's the next lesson.